Hello students, last time we have started new topic alcohols, phenols and ethers, in which we have completed physical properties of alcohols and phenols, and then we have started chemical properties of alcohols and phenols, in which first property we have completed, that is laboratory test for alcohols and phenols, in which we have seen litmus test. We have seen that when red or blue litmus is dipped in alcohol, then there is no change observed in case of litmus paper. But when blue litmus paper is dipped in phenols, then it converted into red litmus paper. From this we can say that alcohols are neutral in nature while phenols are acidic in nature. Then second property we have seen reaction with bases, in which we have seen that when phenols are treated with strong base like aqueous NaOH or aqueous KOH, then formation of sodium phenoxide or potassium phenoxide salt with water molecule. From this we can say that phenols are acidic in nature. But alcohols does not react with bases like sodium carbonate, sodium bicarbonate or with NaOH or KOH. But when these alcohols are reacted with active metals like sodium metal or potassium metal, then formation of sodium alkoxide or potassium alkoxide with evolution of hydrogen gas. This reaction is used to detect alcohols. Now the next reaction we have seen is characteristic test for phenols. Now here, when phenols are treated with neutral aqueous FeCl3 or ferric chloride solution, then the color of phenol changes to green, violet or purple. This is a distinguishing test for phenol. Then we have seen next test, distinguishing test for alcohols. Now here we can distinguish primary, secondary and tertiary alcohols from each other by the action of Lucas reagent. When primary alcohols react with Lucas reagent, then here formation of primary alkyl halide takes place. But primary alkyl halides are less reactive. Lucas reagent is the mixture of concentrated HCl and ZnCl2. Now here, when primary alcohols are heated with Lucas reagent, then formation of primary alkyl halide with water takes place. Secondary alcohols react slowly with Lucas reagent to give secondary alkyl halide, and tertiary alkyl halide fastly react with concentrated HCl to give tertiary alkyl halides. From this reaction we can distinguish primary, secondary and tertiary alcohols. Now we are going to see secondary property of these alcohols and phenols, that is reaction due to breaking of OH bond. Now we know that the functional group of alcohol and phenol is OH, and we are going to see the reaction involving breaking of OH bond. Now first we are going to see acidic nature of alcohols and phenols. Now in lab test we have seen that all these alcohols are neutral while phenols show acidic nature. Now here we are going to see this acidic nature of alcohols, phenols by their ionization. Now when alcohols undergo ionization in water, they form alkoxide ion, that is RO- plus H3O plus. While when phenol undergo ionization in water, it forms phenoxide ion, that is O- and H3O plus. Now here, this alkoxide ion is unstable ion because here the alkyl group which is attached to oxygen atom is electron donating group. It donates electron to oxygen atom by inductive effect, that is electron donating inductive effect. Now here this alkoxide ion of this oxygen atom is electron rich, and when this alkyl group donate electron to this oxygen atom, then electron density of this oxygen atom is increased and it becomes unstable. Therefore, alcohols are neutral. That is, they are or they do not donate H plus ion. That it does not easily undergo ionization in water. But when phenol react with H2 or when it undergo ionization in water, it gives phenoxide ion plus H3O plus ion. Now this phenoxide ion is stabilized by resonance. Because this O minus ion is conjugated with the benzene ring. That is, here resonance occurs like this. That is, this electron pair gets shifted in between this carbon and oxygen atom. Then these pi electrons of benzene ring or phenyl group shifts on this orthocarbon atom to form next resonating structure like this. Then again next resonating structure is like this. This electron pair gets shifted in between these two carbon atoms, and this pi electron gets shifted on para carbon atom to form next resonating structure. Then again same to give next resonating structure. In this way, this phenoxide ion is resonate in the benzene ring or negative charge of this oxygen atom, or electron pair of this oxygen atom can resonate in this benzene ring and therefore can be stabilized by resonance. Therefore, this phenoxide ion formed after ionization of phenol is stable phenoxide ion, and therefore these phenols are acidic in nature while alcohols are neutral in nature. Now, question for you. Arrange the following in decreasing order of acidic strength. Now here, first is ethanol, that is CH3CH2OH. Second is CH3 3 times COH. Third is C6H5OH. And fourth one is para-nitrophenol, that is PNO2C6H4OH. Now here we know that phenols are more acidic than that of alcohols, or alcohols are neutral. Now first we are going to compare the alcohols, these two alcohols. These alcohols are neutral, but depending upon the nature of alkyl group attached to hydroxy group, these compounds can be, or alcohols can be compared, or their acidity can be compared. Now here, if this alcohol, that is ethanol, is ionized in water, then it forms ethoxide ion. And when this tertiary butyl alcohol is ionized, then it forms tertiary butoxide ion, like this. Now, this tertiary butoxide ion is less stable than that of ethoxide ion, because here this oxygen ion, that is O minus ion, is attached to this 4 carbon atom, that is electron donating alkyl group, that is tertiary butyl alkyl group, and therefore this O minus ion is least stable, because first here the electron density of this oxygen ion is more, and these groups, or this tertiary butyl group, is also electron donating. It donates electrons by inductive effect to this oxygen ion, and therefore electron density of this oxygen ion again increases and therefore it becomes less stable. Now here, as compared to this, here there is only one alkyl group, that is ethyl group, and therefore the electron density of this oxygen atom is also higher by electron donating effect or inductive effect of this ethyl group. But as compared to this, it is less. Therefore, we can give the preference for this is 4. That is, it is least acidic in nature as compared to this ethanol. Then for this ethanol we give third number. Now we are going to compare the acidic strength of these two phenols. One is simple phenol and second is para-nitrophenol. Now here this is phenol and this is para-nitrophenol. Now this nitro group is electron withdrawing group, which withdraw electron from the benzene ring by resonance effect. Now when these phenols are created with water molecule, they undergo ionization to form phenoxide ion and para-nitrophenoxide ion. Now this phenoxide ion of this phenol are stabilized by benzene ring. Here this oxygen atom or negative charge on oxygen atom is stabilized by resonance effect like this. Now in this case, this NO2 group is electron withdrawing group. Therefore, it withdraws electron from benzene ring and similarly from this oxygen ion, and therefore electron resonate in such a way. And therefore, electron density of this oxygen atom becomes less as compared to that of this oxygen atom, which is attached to only C6H4. And therefore, the acidic strength of this para-nitrophenol is higher than that of this simple phenol. Therefore, we give number this 1 and this 2. That is, this is 1 number and this is 2 number. Therefore, we can write the decreasing order of this acidic strength of this following compound like this: para-nitro C6H4OH, which is most acidic, then C6H5OH, then CH3CH2OH, and then CH3 3 times COH. Now here we are going to see second reaction, that is reaction due to breaking of OH bond, in which we are going to see second reaction, esterification. Now here, when these alcohols and phenols are reacted with carboxylic acid in presence of concentrated H2SO4, that is acidic medium must be concentrated. That is, this reaction is carried out in presence of concentrated H2SO4. This H2SO4 acts as a catalyst also and acts as a dehydrating agent. Now here, when these alcohols are reacted with carboxylic acid, now here this carboxylic acid is written like this: R C double bond O OH. The functional group of carboxylic acid is C double bond O OH. Now this is carboxylic acid, and when this alcohol is reacted with this carboxylic acid in presence of concentrated H2SO4, then here removal of H2O, that is breaking of this OH bond takes place like this. H2O is removed and this R get attached to this carbonyl group to form R C double bond O, R O C double bond O R dash plus H2O. This reaction is reversible reaction. If acid is not used, then this reaction is reversible reaction. But we are going to use this concentrated H2SO4. This concentrated H2SO4 acts as a catalyst to form ester and also it acts as a dehydrating agent. If this H2O is removed, then backward reaction is not carried out. This compound is ester. Here formation of ester takes place. Therefore, this reaction is named as esterification reaction, or it is also named as Fischer esterification reaction. Now here, this is alcohol. When it reacts with carboxylic acid, gives ester with removal of H2O. This concentrated H2SO4 acts as a catalyst, which increases the rate of reaction and acts as a dehydrating agent. Now here phenol. When this phenol is reacted with this carboxylic acid, this is also carboxylic acid, that is R dash C double bond O OH. Now this reaction is also carried out in presence of concentrated H2SO4 or in acidic medium. Breaking of this bond takes place like this. H2O is removed and this ARO get attached to this carbonyl group to form ARO C double bond O R dash. This is ester plus H2O. The esterification of alcohols and phenols can also be carried out by using acid anhydride. Now this is alcohol and this is acid anhydride. Here this is phenol and this compound is acid anhydride. Now what is meant by acid anhydride or how it is formed? Acid anhydride is formed by the reaction of or dehydration of two molecules of carboxylic acid. Now this is one carboxylic acid molecule, this is second. If we take here R dash, then this reaction is carried out in presence of phosphorus pentoxide. Phosphorus pentoxide is dehydrating agent. It removes H2O molecule from two carboxylic acid. Both are similar. R dash C double bond OH, R dash C double bond OH. These are carboxylic acid. And from these two carboxylic acid, H2O molecule is removed. And we get here R dash C double bond O C double bond O R dash. That is here H2O is removed and this COR group get attached to this oxygen atom to form this acid anhydride. In this way, this acid anhydride is formed by the intermolecular dehydration of two similar carboxylic acid in presence of phosphorus pentoxide. Now here, when this alcohol is treated with acid anhydride, then here esterification takes place. This reaction is carried out in presence of concentrated H2SO4. That is, in acidic medium, this reaction is carried out. Now what happens here? Breaking of this HO bond takes place like this. Here OH bond breaks. Now here also this bond breaks in this way. And we get RO C double bond O R dash and R dash C double bond O OH like this. We'll get here R O C double bond O R dash plus R dash C double bond O OH. That is, here we get ester along with carboxylic acid. This is the second method for the preparation of ester or reaction of alcohol with acid anhydride to form ester. That is, here also formation of esters takes place. Now here these are phenols. When these phenols are created with this acid anhydride, that is R dash C double bond O C double bond O R dash, then here this phenol react with this acid anhydride in acidic medium, and here breaking of this bond takes place. That is, OH bond breaks here, and here same like this breaking takes place to form ARO C double bond O R dash. This C double bond O R dash plus R dash C double bond O OH. This is carboxylic acid. This compound is also carboxylic acid and this compound is ester. But this ester is aromatic ester. In this way, alcohols and phenols are converted into ester. This reaction is also named as esterification reaction, but this is carried out by using acid anhydride. We have seen esterification of alcohols and phenols by using carboxylic acid, then by using acid anhydride. Now we are going to see the esterification of alcohol by using acid chloride. Now the structure of acid chloride is RC double bond OCl. This compound is acid chloride. Now when this acid chloride is treated with alcohol, then here simple removal of HCl takes place. And this R get attached to RO group get attached to this carbonyl group to form ester. This reaction is carried out in presence of pyridine. Pyridine is a base which absorbs this HCl form and then backward reaction is prohibited. That is, only forward reaction is carried out due to use of this pyridine, which is used as a base which neutralizes this HCl. And then we will get only ester. Here we will get ester R O C double bond O R dash. This is ester plus HCl. Now this alcohol is converted into ester. Now we are going to see phenol. And phenol is reacted with this acid chloride, that is R dash C double bond OCl in presence of pyridine. Same reaction takes place. Here this OH bond breaks and this H get attached to this Cl, then this ARO get attached to this carbonyl group to form ARO C double bond O R dash plus HCl. This is ester, but this ester is aromatic ester. That is, in this way we can convert alcohols and phenols into ester by using carboxylic acid, by using acid anhydride and by using acid chloride also. Now we are going to see some examples. Now here, if we use acetic acid, this is CH3 C double bond OH, and alcohol, if we take example of this CH3 CH2OH, then here this ethanol will react with this acetic acid in presence of concentrated H2SO4. Then esterification takes place to form CH3 C double bond O CH2 CH3 plus H2O. Now here, from this ethanol, this hydrogen atom is removed, and from this acid OH is removed, H2O is removed, and this OCH2CH3 group get attached to this carbonyl carbon of acetic acid, and we get here CH3 C double bond O CH2CH3 plus H2O. This compound is ethyl acetate. Now this phenol, when it is treated with acetic acid, then here this OH group, OH bond breaks, and this OH group is removed to form H2O, and this phenoxide ion get attached to this CH3CO group. Then we get here O C double bond O CH3 plus H2O. Now this compound and this compound. This compound is called as acetate group of or acetyl derivative of. This is ethyl acetate and this is acetyl derivative. That is, acetyl group is substituted. Therefore, it is acetyl derivatives of this ethanol. Or if it is general alcohol, then it is acetyl derivative of alcohol, and this compound is acetyl. This is acetyl group. Therefore, it is acetyl derivative of phenol. These are the acetyl derivative of alcohol and these are acetyl derivatives of phenols. acetate ester of alcohol is CH3 C double bond OR, in which the hydrogen atom from alcohol, now this is alcohol part and this is carboxylic acid or acetic acid part. Now here hydrogen atom from this alcohol is replaced by COCH3 group. This CH3CO group is known as acetate or acetyl group. Now this is acetyl derivative of alcohol, and similarly acetyl derivative of phenol is CH3 C double bond OR. Now here this is from phenol part, that is ArOH, and this hydrogen atom from phenol is replaced by CH3CO group. Therefore it is acetate ester of phenol or acetate ester of alcohol. That is, these alcohols are named as acetyl derivatives of alcohols or acetyl derivatives of phenols. Now these acetyl derivatives of alcohols and acetyl derivatives of phenols are formed by the reaction of alcohols and phenols acetic acid. Now here, when acidification of alcohols and phenol is carried out, then here we get acetate ester of corresponding alcohol or phenol. Now if this reaction is used to identify the number of hydroxy group present in the alcohols or phenol, that is, when these alcohols containing one or more than one hydroxy group are created with acetic acid, then we'll get acetyl derivatives of all hydroxy group, and we can identify how many hydroxy group present in alcohols and phenols. Now in esterification we are going to see the preparation of aspirin, that is acetic salicylic acid. Now aspirin is a generic medicine which is used as a painkiller, or it is analgesic in nature. Now here this salicylic acid, structure of salicylic acid is like this. Here this is benzene which is attached to OH group, and at ortho position of this OH group there is carboxylic acid group, that is COOH group. Therefore the name of this compound is, or common name of this compound is salicylic acid. IUPAC name of this compound is 2-hydroxybenzoic acid. Now this is acetic anhydride, CH3 C double bond OOCOCH3. Now here, when this acid, salicylic acid, actually it is phenol, but at its ortho position there is carboxylic group, therefore it is acid. Salicylic acid, when it is treated with acetic anhydride, then acetylation of this OH group takes place. And here, this hydrogen atom or this OH bond breaks, and this hydrogen atom breaks and get attached to this CH3 C double bond OO group. That is, here formation of CH3 C double bond OOH. And this COCH3 group get attached to this oxygen atom. That is, acetylation of this hydroxy group is carried out to form this compound plus CH3 C double bond OH. This is acetic acid. Now this compound is acetic salicylic acid. Acetic salicylic acid, or it is also named as aspirin. Aspirin is a painkiller or analgesic. It is a generic medicine. Next reaction we are going to see is reaction due to breaking of CO bond. Now here we have seen that in alcohol COH group is present, or in phenol also there is presence of COH group. This is COH group. Now we are going to see the breaking of or the reactions involving breaking of CO bond. Now here, first reaction we are going to see is reaction with hydrogen halide. Now hydrogen halide means HX, where X is any hydrogen atom, either it is chlorine, bromine and iodine. Now here this HX is nothing but HI, that is hydrogen iodide, or HBr, that is hydrogen bromide, or HCl, that is hydrogen chloride. Now here HI is more reactive than HBr and then HCl. HCl is least reactive. Now here this reaction of alcohols with hydrogen halides we have seen in halogen derivatives, that is in topic 10, preparation of alkyl halides by using alcohols. Now we are only summarize these reactions. When alcohol is treated with Lucas reagent, yesterday we have seen this reaction. Lucas reagent, that is mixture of concentrated HCl and ZnCl2. Now when alcohol is treated with or heated with Lucas reagent, then we will get RCl plus H2O. That is alkyl chloride is obtained. Here the mole of this H2O takes place and hydroxy group is substituted by chlorine to form alkyl halide. Now here we have seen last time that tertiary alcohols are more reactive than secondary alcohols and secondary alcohols are more reactive than primary alcohol. Now here this is first with HCl. Then second, when alcohols are treated with HBr. Now this HBr is unstable, therefore it is prepared at the time of reaction in presence of NaBr and H2SO4. Heat this reaction mixture. First this NaBr and H2SO4 react with each other to form HBr, and then this HBr react with alcohol to form RBr plus H2O. That is alkyl bromides are formed here. And when alcohols are treated with hydrogen iodide, that is HR, in presence of NaI, that is sodium iodide, and H3PO4, that is phosphoric acid, then here formation of Ri plus H2O takes place. In this way, alcohols are converted into alkyl halides by the action of hydrogen halide. This reaction is repetition. We have seen this reaction in halogen derivative in the preparation of alkyl halides from alcohols. Now we are going to see next reaction or second reaction, which involves breaking of CO bond. Reaction with phosphorus halide, that is phosphorus trihalides or phosphorus pentahalides. Now this reaction also we have seen in halogen derivatives in the preparation of alkyl halides by using alcohols. Now here, when alcohols are reacted with phosphorus trichloride in presence of pyridine, reflux this reaction mixture, then here formation of RCl, that is alkyl chloride, plus H3PO3 is obtained, that is phosphoric acid is obtained. Now we have to balance this reaction. Here there are 3 chlorine, therefore we have to write here 3. Now here also we have to write thrice. Now this reaction is balanced reaction. That is when alcohols are treated with PCl3, that is phosphorus trichloride, then formation of alkyl chloride takes place. And when this alcohol is treated with phosphorus pentachloride, then here formation of RCl plus POCl3 plus HCl. Formation of RCl plus POCl3 plus HCl takes place. How this reaction takes place? Look here. Here PCl5. Now here POCl3 is formed like this. This H get attached to this Cl, this R get attached to this Cl to form RCl plus POCl3 plus HCl. Now here we are going to see formation of alkyl bromides and alkyl iodides using phosphorus trihalide and phosphorus pentahalide. Now here like PCl3, PBr3 or PBr5 or PI3 or PI5 are unstable and they are prepared at the time of reaction by the reaction between red phosphorus and bromine molecule to form reflux this, that is red phosphorus is treated with bromine molecule to form PBr3. We have to balance this reaction. Here there are 3 bromine and here there are only 2 bromine. Therefore we have to write here 3 molecules. That is, it becomes 3Br2. Now here write twice. Then it becomes red phosphorus becomes 2 molecules. This is balanced reaction. 2 PBr3 are formed. Similarly, when red phosphorus is treated with bromine molecule, we will get PBr5. Now here also we have to balance this reaction. Write here twice, then it becomes 10, here write 5 and it becomes 2P plus 5Br2 is 2 molecules of PBr5. Now first this reaction is carried out and then reaction between alcohol and PBr3 and PBr5 is carried out. Now how the reaction takes place? Look here. When alcohol is treated with PBr3, that is phosphorus tribromide. Now how it is obtained? By the reaction between red phosphorus and Br2 molecule. Therefore we must write here red phosphorus and Br2 at arrow. Reflux this, then here formation of RBr plus H3PO3 is obtained, that is phosphoric acid is obtained. Here formation of alkyl bromide plus H3PO3 takes place. Now here we have to balance this reaction. There are 3 bromine and here there is only 1. Therefore write here thrice, then here thrice. Then this is balanced reaction. Now if we carry out this reaction with PBr5, then same like phosphorus pentachloride, same reaction takes place. But here write red phosphorus plus Br2 molecule, hit this or reflux this, then you will get here RBr plus H3PO3, POBr3 plus HBr. Same reaction takes place like here, like phosphorus trichloride, Cl, Cl, here Cl3. That is, this is PCl5, breaking of this takes place, Br here. Breaking of this POBr3 and RBr and HBr. RBr, POBr3, HBr is formed. Similar reaction is carried out with iodine or phosphorus triiodide and phosphorus pentaiodide, like this. Now here red phosphorus first refluxed with iodine molecule to form PI3. We have to balance this reaction. Here write twice, here write thrice, here write twice. Reflux this. You will get first PI3. Then if you prepare PI5, that is phosphorus pentaiodide, then reflux this. You have to balance this reaction. Write 5 here, here twice, here twice. Then you will get PI5. Now first this PI5 and PI3, that is phosphorus triiodide and phosphorus pentaiodide, are also unstable and therefore they are prepared at the time of reaction like this, and then the reaction is carried out. For example, ROH plus PI3. Reflux in presence of red phosphorus and iodine molecule. Then you will get here Ri plus H3PO3. We have to balance this reaction. Right here thrice, then here also thrice. This is balanced reaction. Similar reaction is carried out with PI5. Reflux red phosphorus with iodine molecule. Hit this reaction mixture, you will get Ri plus POI3 plus HI. Here same reaction is carried out, Pi3. Here POI, P is removed, R gate attached to Ri to form Ri. POI3 is removed plus HI. In this way, alkyl iodides are prepared by using phosphorus triiodide and phosphorus pentaiodide. This reaction we have seen in halogen derivatives in the preparation of alkyl halides from alcohols. Third reaction we are going to see under the reaction of breaking of CO bond. Here dehydration of alcohols to alkene. Now these reactions we have seen in 11th standard in the preparation of alkenes from alcohols. Alkenes are prepared by using alcohols. Now here this is primary alcohol. When this primary alcohol is treated with 95% concentrated H2SO4 and at 443 Kelvin temperature, then here alpha beta elimination is carried out. Now here the carbon atom which is bonded to functional group is called as alpha carbon atom, and the carbon atom next to alpha carbon atom is known as beta carbon atom. Now here alpha beta elimination or 1,2 elimination takes place like this. This OH bond breaks. Here also this CH bond breaks, but this OH group is more electronegative, therefore it withdraws electrons from this group towards itself, and therefore this hydrogen atom removes H plus ion by giving both bonded electron in between these two carbon atoms, and this OH group is removed as OH minus ion. This OH minus ion get attached to this H plus ion to form alkene, that is CH2 double bond CH2 plus H2O. Now this is primary alcohol, therefore we have to use drastic condition, that is more concentrated H2SO4 and higher temperature to form ethene. Here formation of ethene takes place with the removal of H2O. Now we know that what is meant by dehydration. The reaction in which water molecule is removed is called as dehydration, and here simple dehydration is carried out. Now here this is secondary alcohol, CH3, CHOH, CH3. Now this is alpha carbon atom, this is beta, and this is also beta. Now this is secondary carbon atom which is more reactive, therefore we have to use lower concentration of H2SO4, that is 60% H2SO4, and at 373 Kelvin temperature, here we will get CH3, CH, double bond, CH2 plus H2O. This is propene. This compound is propene. Now here, this is secondary alcohol. Now we are going to see this reaction, third. This is tertiary alcohol, that is tertiary butyl alcohol. Now this tertiary butyl alcohol is most reactive. Therefore, it easily undergoes dehydration in 20% H2SO4 at 363 Kelvin temperature to form CH3, CH3 double bond CH2. That is isobutylene. Formation of isobutylene takes place with removal of H2O molecule. In this way, primary, secondary and tertiary alcohols undergo dehydration to form these alkenes. Now here tertiary alcohols are more reactive than secondary alcohols, and secondary alcohols are more reactive than primary alcohols. This dehydration of alcohol is also carried out by using alumina, that is Al2O3, or by using silica, SiO2. These are dehydrating agent. That is, this catalyst also used to dehydrate these alcohols into corresponding alkenes. Now, in dehydration of alcohols to alkenes, we are going to see ZZ2. If we carry out the dehydration of butane to OL, the structure of butane to OL is CH3CHOH, CH2, CH3. Now here, this carbon atom is alpha carbon atom, and this alpha carbon atom is bonded to two beta carbon atom. Then here possibility of two products. If this hydrogen atom is removed with this OH group, then here formation of but1ene takes place. And if this hydrogen atom is removed with this OH group, then we will get but2ene. That is possibility of two products are there, like this. If this alpha beta elimination is carried out, then you will get CH2 double bond CH, CH2, CH3. That is, this is but1ene. And if elimination of this hydrogen with this hydroxy group is carried out, then you will get CH3, CH, double bond, CH, CH3. This compound is but2ene. That is, here mixture of two products are obtained. But according to Sedgwick rule, we have seen this Sedgwick rule in halogen. We have seen this Sedgwick rule in halogen derivatives. Similarly, here alpha beta elimination takes place to obtain but1ene and but2ene. But according to Sedgwick rule, more substituted product is obtained as a major product. Now here, this more substituted alkene is but2ene. Here CH double bond CH is bonded to two alkyl group, that is methyl and this one methyl, that is two methyl group. Therefore, more substituted alkene is obtained as a major product. And this is minor product because this alkene is least substituted. In this case, this double bonded carbon atom is bonded to only ethyl group. Therefore, this is least substituted alkene, that is but1ene, which is obtained as a minor product. This is according to Sedgwick rule. Homework for you. First question. Give preparation of ethyl acetate using ethanol and acetic acid. Question number 2. Give preparation of methyl acetate using methanol and acetyl chloride. Question number 3. Give preparation of ethyl acetate using ethanol and acetic anhydride. Question number 4. How will you differentiate propane 1OL, second propane 2OL, and third 2-methyl propane 2OL by their dehydration reaction?